Hi dear students, in the last class we discussed the one-dimensional Dirac delta function and also we did few problems, and the identity that we used for solving those problems was minus infinity to infinity f of x delta x minus a dx is equal to f of a. The problems that we did in this session were this one. In these problems, the delta x minus 3, where the x has a coefficient 1, here also the x has a coefficient 1, here also x is equal to 1, here also a coefficient of x is equal to 1. But when we do the problems like this one, here delta 3x, where the x has a coefficient 3, then what we will do is we will use a new identity. That identity is this one, that is delta is multiplied with any constant k, that is a non-zero constant kx, then it should be written as 1 by k delta x, where k is any constant that is non-zero constant. This is the new identity, new information that you have to keep in mind. For example, in this question, that is, if delta is 3x, here we have to take this as a 1 by 3 delta x. Okay, now let us do the few problems. So first, the question is problems 1.44. Evaluate the following integrals. These are the unsolved problem in the Griffith textbook. Here the first question is integration of minus 2 to 2 with 2x plus 3 delta 3x dx. I will write the question here, minus 2 to 2 2x plus 3 delta 3x dx. Here we have to use that identity. I will rewrite this equation. This minus 2 to 2 2x plus 3. Here this should be written as 1 by 3 delta x. Is 1 by 3 delta x dx. Okay. That is, totally this equation can be written as 1 by 3 minus 2 to 2 2x plus 3 delta x dx. Now I can compare it to the standard equation. The standard equation was this one, minus infinity to infinity f of x delta x minus a dx is equal to f of a. I can compare this term only, that is this term. Here the left hand side I have this 1 by 3. If I compare, f of x is nothing but 2x plus 3 and x minus a, here I don't have a here, but I can slightly rewrite this or modify this equation like this one, x minus 0 dx. Therefore a is nothing but 0. Now let us see how to proceed this problem. We have obtained f of x is equal to 2x plus 3 and a is equal to 0, and the 0 lies between the domain of the integral, that is minus 2 to plus 2. That is, if I draw here, this will be our lower limit minus 2, this is upper limit plus 2, then the value of a exactly lies in between, that is at 0. Therefore the spike comes here, 0. Therefore, the value of this integration never be 0. Well, the answer, the value of the integration will be f of a. Therefore, what I can do is I can find out f of a, that is f of 0, that is 2 into 0 plus 3 means that is nothing but 3. Therefore, this result of this part, that is 3, then what will be the final answer? The final answer of this integration is 1 by 3, that is already we have here, that 1 by 3 into 3 is nothing but 1. Therefore, the answer of this integration is 1. Okay, let us do the second problem. The second problem, that is 0 to 2 x cube plus 3x plus 2 delta 1 minus x dx. 0 to 2, question B, x cube plus 3x plus 2 into delta 1 minus x dx. Here the standard equation takes this form: minus infinity to infinity f of x delta x minus a dx is equal to f of a. If we compare these two equations, this is nothing but our f of x, that is f of x can be written as x cube plus 3x plus 2, but here if you compare delta x minus a, here we have delta 1 minus x. This is not in the slightly we have to rearrange this term. Here one important information, that is delta of minus x is nothing but delta x. This is very important that you have to keep in your mind. Therefore, I can write this equation as, that is, instead of 1 minus x, I can write, if I take the negative outside, then this will be x minus 1, but negative of delta x is positive, therefore this is simply x minus 1. So from here I can write our f of a is nothing but 1. Compare this and this one. Now one more thing, we have to check whether this value of a comes within the domain of the integral 0 or 2, this equation. Okay. This is the lower limit is 0, upper limit of the integral is 2. Of course, the 1 will be here. Therefore, the peak appears, or the spike appears exactly at 1. That will lies inside the domain of the integral 0 and 2. Therefore, the answer of this integral never be 0. Then, as usual, you can proceed by finding out the value of a, that is f of 1, that is 1 cube plus 3 into 1 plus 2 is 1 plus 3 plus 2, that is 6. Therefore, the value of the integral second is 6. Now, what about the third one, C? I will copy the question C here. That is, question C is minus 1 to 1 9x square delta 3x plus 1 dx. This can be written as minus 1 to 1 9x square. Here we have to use that identity. What is that identity? We have to write 1 by 3 delta x plus here 1 by 3. To take 3 outside, then here should be 1 by 3. Okay, you have to write in this fashion. Dx written as 1 by 3 minus 1 to 1 9x square plus delta into delta x plus 1 by 3 dx. Now for this part you can write the standard equation. That is, standard equation was minus infinity to infinity f of x delta x minus a dx. Compare. On comparison, you will note that f of x is 9x square and the value of a is minus 1 by 3. A is equal to minus 1 by 3. Now you have to check whether this value of a is coming within the domain of the integral minus 1 to 1. If I draw here, the lower limit is minus 1, upper limit is 1, the minus 1 by 3 come exactly here, which means exactly here means within the limit minus 1 and 1. Therefore our peak will be like this. Okay, therefore the value of this this integral never be 0. We have to find out the value of this integral. Value of that integral is nothing but this f of a according to this general expression. Here a is minus 1 by 3. Therefore this is 9 into minus 1 by 3 square, that is 9 into 1 by 9 equal to 1. Therefore what will be the result of this integration? The result of this integration is 1 by 3 into this is value is what we have obtained. This value is f of minus 1 by 3, that we obtained is 1. That is the answer is 1 by 3. Okay. Now we have obtained the third answer. This is 1 by 3. The fourth one you can do as a homework. This is a very simple question. Keeping all this statics in your mind, now let us move to the next topic, that is a three-dimensional delta function. That is, we discussed the three-dimensional delta function. The three-dimensional delta function can be written as delta function in 3D. That is, delta cube r is equal to delta x, delta y, delta z. Okay, where this r is a vector, that vector r is x cap plus y cap plus z cap. This is nothing but the position vector extending from the origin to the point x, y, z. We have seen the three-dimensional delta function earlier also. That is in the case where we derived this quantity, that is delta dot r cap by r square, divergence of r cap by r square. The result that we obtained was this one, 4 pi delta cube r. Actually, this is a three-dimensional delta function. That three-dimensional delta function has this property, that is a volume integral of three-dimensional delta function is equal to 1. This volume integral delta cube r d tau is equal to 1, where at the origin, that is when r is equal to 0, at the origin the three-dimensional delta cube function has value equal to 1, and except all other points the volume integral delta cube r d tau is equal to 0. That can be written in this way when r is not equal to 0. This is the story about three-dimensional delta function. Or more precisely, I can write in this way: the three-dimensional delta function is 0 everywhere except at the origin, that is the point 0, 0, 0. Here the 0, 0, 0 means x is 0, y is 0, z 0. Okay, I would like to introduce one more identity in the case of the three-dimensional delta function. Before going to that, I would like to draw your attention on the one-dimensional delta function. That identity we used in one-dimensional delta function was this one. One-dimensional delta function is minus infinity to infinity f of x delta x minus a dx is equal to f of a. In three-dimensional delta function, okay, this is all space, and instead of x this will be fr, and this will be delta cube r minus a d tau is equal to f of a. Okay, this is very important identity. We will use this identity to solve all the problems in the three-dimensional delta function. Therefore, this should be noted. Okay, now let us do a few problems. This is the first problem in the three-dimensional delta function. That is, evaluate the integral j is equal to the whole space integral, where the whole space there is a sphere, that is r square plus 2 divergence of r cap by r square d. I copy this question here. J is equal to the whole space, it is nothing but sphere, r square plus 2 del dot r cap by r square d. The sphere has a radius r that is given in the question. To solve this problem, we have to use this idea, that is, already we have the answer of the divergence of r cap by r square, that is r del dot r cap by r square is nothing but 4 pi delta cube r. Let me substitute this value here. That is, j is equal to whole space integral r square plus 2. This is 4 pi delta cube r d tau. Here this 4 pi I can bring to here. This 4 pi volume integral r square plus 2 delta cube r d tau. Then what is the standard integral? The standard integral just now we have written here. This is the standard integral in three-dimensional delta function. We can use this expression to solve this kind of problems. That is, compare the standard integral. The standard integral, that is all space f of r delta cube r minus a d tau is equal to f of a. I can compare these term only. Still that 4 pi is here. Let me write here. Then on comparison, what you will get? On comparison, we will get f of r is r square plus 2, and a, here I don't have a, but slightly I can modify this equation, can be written as r minus 0. Therefore, a is equal to 0 here. This is our a. A is equal to 0. Then this a is equal to 0 comes well inside the radius. Therefore, the integral of this, the result of this integral never be 0, because the radius starts from 0 to r. Fine. Now, if this is the case, what will be the answer? That is, this 0 to r is our limit, and our this a comes here. Fine. Then f of 0, that is 0 square plus 2, is nothing but 2. Therefore, answer of this one is 2. Because we know that f of a will be the answer of this integral. Here the f of a, we have seen that is f of 0, that is this 2. Now, we can write for pi into this is 2, final answer is 8 pi. Therefore, this answer of this question is 8 pi. This is the answer. Okay, now let us move to other problems. These are the unsolved problem in the Griffith textbook. That is, evaluate the following integrals. First question A, that is all space r square plus r dot a. The r and a both are bolded, therefore there is vector quantity. And delta cube r minus a, this is also vector quantity. Where a means this vector a is a fixed vector and a is its magnitude. Okay, let us do this problem first. I will copy this question here. All space r square plus r dot a plus a square delta cube r minus a d-tau. Fine. What we will do? Let us compare with the standard equation. All space f of r delta cube r minus a d-tau is equal to f of a. Okay, well, this is very clear. This is nothing but our f of r, and our a is here a. This f of r is equal to r square plus r dot a plus a square. Then f of a, that is a square plus a dot a plus a square plus a square plus a square, it is nothing but 3a square. 3a square is the final answer. Okay. Thus for this has a value 3a square. It's a simple question, nothing to do or nothing to think about it. Now let us come to the second question B. In the second question, that is volume integral r minus b whole square delta cube 5r d tau, where v, where is the whole space, that is nothing but a cube of side 2 centered on the origin, and b, this b means this is the bolded one, it means it is a vector quantity. B is equal to 4y plus 3 z cap. Therefore, first I will copy this question here. It is volume r minus b whole square delta cube 5r d tau, and the whole space here, this is nothing but the cube. And another thing information given is vector b is equal to 4y cap plus 3 z cap. Okay, here I should use the identity. See, that is, this is a del cube 5r. I can rewrite this equation in this way. The whole space, that is nothing but the cube, r minus b whole square. Here I should take the 5 cube outside, then delta cube r d tau, because Um, if it was delta 5r, then the answer will be 1 by r delta r. Since it is a delta cube 5r, this is a cube, therefore I have to take 5 cube delta r. That should be very careful. The students do the mistake here. Simply they will take 5 instead of 5 cube in the case of delta cube. Therefore, this should be del 5 cube, not 5. And this can be written as 1 by 5 cube volume integral r minus b square delta cube r d2. Now I can write the standard integral. The standard integral that is all space f of r delta cube r minus a d2 is equal to f of a. If you compare these two equations, then our f of r is this one. That is very clear. R minus b whole square is our f of r, but there is no a. But I can rewrite this delta cube as r minus a. Sorry, r minus 0. Then on comparison you will come to know that a is nothing but 0. Therefore we have the information a is equal to 0. Then f of a, that is f of 0, means substitute in the equation, that is f of r. Already we have r minus b whole square. F of 0 means 0 minus b whole square. This is equal to b square. Then what is the b square? Look at here. It is already given in the question. That is vector b is given. B square is b dot b. Take the dot product, then it will be 4 square plus 3 square is 16 plus 9, that is nothing but 25. Therefore, we got this result, this part, that is this part, the result is 25, but here we have this 1 by 5 cube. The final answer is 1 by 5 cube into 25, that is 1 by 5 cube into 5 square. Answer is 1 by 5. Therefore, the final answer of the question B, this is 1 by 5. The remaining two questions, question C and question D, you can do it as a homework. This is a very simple question. Be careful that here it is given this volume integral, and where v is the sphere of radius r about the origin. You have to check first whether this radius r comes within this domain of the integral. Okay, that has to be checked, because whether it will come within the domain of the integral or not, that can be checked if you take the c square. If the c square, first to find out c square, then find the value of c. If the c is greater than 6, this integration answer will be 0. Otherwise, the integration answer will be, some values will be there. You can also the D question also. Okay, thank you very much for watching this video.